Today, I'd like to talk about the last of our convergence tests. This would be the root test and the ratio test. As usual, I'm going to split this up into the what and the why. Right now, I'm only going to be concerned with what these tests say and examples of how to use them. We're going to be thinking about an infinite series, the sum I equal 1 to infinity a sub I. The root test says this: if you take term number n, take its absolute value, take the nth root of that, and take the limit as n tends to infinity, what the value of that limit is tells you some stuff about the series. If that limit exists and is smaller than 1, the infinite series in question converges absolutely. If the limit's bigger than 1, including the case where it diverges, then the series fails to converge, it diverges. And if the limit comes up exactly equal to 1, as we'll see shortly, we are unable to make any statement about convergence or divergence based on just this information. For example, think of the sum n equals 0 to infinity of 3n plus 1 over 4n plus 5 raised to the n power. If I take the absolute value of each term, I'll have the absolute value of 3n plus 1 over 4n plus 5 raised to the n power. Take the nth root of that. Since 3n plus 1 over 4n plus 5 is positive, I can drop the absolute value, work out the limit, and get 3/4. By the root test, the infinite series we started with converges absolutely. As another example, let's look at the sum n equal 1 to infinity, negative 1 to the n plus 1 power, divided by n to the n. Writing out the required limit, we find out that it's 0. By the root test, the series in question converges absolutely. The last of our convergence tests is called the ratio test. If I have an infinite series, what I can do is I can take the limit of the absolute value of a term of the series divided by the preceding term. If that limit exists and is less than 1, the series converges absolutely. If the limit is more than 1, including the case where it diverges, then the infinite series diverges. And if the limit works out to equal 1 exactly, we'll be unable to draw a conclusion. For example, let's look at the sum negative 1 to the n plus 1 n squared over 3 to the n power. I'll write out the generic nth term, the generic n plus first term, calculate the ratio of the larger indexed term over the smaller one, carry the calculus out to do the limit, or use the algebra trick as we've done before. It turns out that the limit of absolute an plus 1 over an works out to be 1/3. For this reason, the ratio test tells me that the infinite series in question converges absolutely. Finally, it turns out that this ratio test fails on some relatively simple series that we're already aware of. Think of the sum I equal 1 to infinity 1 over I squared. This converges because it's a p-series with p equal to 2. But if I work out what the limit is, it comes up exactly equal to 1, and the ratio test fails to say anything. coming up soon is why is it that the root and ratio tests work as they do? Until then, I hope everybody has a good day, and I'll talk to you again soon.